1 through 6 going in formulas. Number 14, super tiny. Oh my. You were supposed to find sine, cosine, and tangent of negative pi over 12, which was impossible with the unit circle unless you used their trick or their clue, which was exactly, I shouldn't say exactly, very, 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 very similar to the first example we did in our notes. We said, oh, we can't do that guy. All right, cool. Let's do this guy. Should you have distributed sin?
Never distributes.
Never. Thank you, thank you, thank you. You got to use your formula, right? So sine, cosine, cosine, sine. I would have written that way. Anyway. Sine, cosine, cosine, sine. Then they substituted in the unit circle values. Double check your work. The most common mistake I see on these problems, if you know the formula, which nice thing is Thursday, you have all the formulas, right? Even if you have the formulas, you properly go here. The most common mistake is you keep the sine and the cosine and the sine and the cosine with these numbers. That is completely wrong because the sine of pi over 6 equals, is substituted for, comes out, and the answer comes in 1/2. So once you plug in the unit circle, all the trig is gone because you found it. It's right there. No more trig. Now it's just numbers. Multiply, multiply. PEMDAS says multiply first and then subtract. If they wrote it like that, you could have also written it all nice and multiplied out like square root of 2 minus square root of 6 all over 4. Same thing. Same thing. AJ.
Isn't the formula sine of u cosine of u?
Yeah. What I just said is I would have written it sine, cosine, but see, instead of switching the sine and cosine, they switched the angles. So it means the same thing. But I would have written it sine pi over 6, cosine pi over 4, cosine pi over 6, sine of pi over 4. They just, there we go. So you guys can go ahead and check the other ones. Let me show you what the other ones would look like if you hadn't done the weird factor out thingamabobs. If you distributed, that'd be square root of 6 plus square root of 2 all over 4. That one's the same thing. And this one, you guys can check what it was before simplifying. For those of you guys that like my trick, instead of common denominators, I would have circled the 3, and I would have multiplied top and bottom by 3, right? The 3 on top would have canceled with that guy, so you just have root 3. Then you would have gotten root 3 minus 3 on top. Oh, what does that mean? Messes me all up. Oh, Siento, give me a second. Come on. No? All right, then you come here. That didn't work either. Come on. And now all the random stuff is down there. Anyway, when you would go ahead and do that trick of multiplying top and bottom by square root of 3, let's see if I can write up here better. You would have ended up with square root of 3 minus 3 all over 3 plus root 3. But guys, they didn't stop there. They remembered to rationalize when you have radicals and a plus or a minus, you have to multiply by the conjugate of the denominator. That's the only way to rationalize, to simplify. And when you simplify, you have to FOIL the top, which would end up with 3 root 3 plus 3 root 3, so 6 root 3. 3 root 3 plus 3 root 3, 6 root 3. Good. And then you would end up with minus 3 minus 9, so minus 12. All over 3, the outer inner cancel, minus 3, sorry, 9 minus 3, it should be 6. After foiling and simplifying. And then you would see, hey, there's 6's like in everybody's. Let's pull out a 6. And when you pull out a 6 from the numerator, you end up with 6 times root 3 minus 2 all over 6. The 6 is reduced, and you get negative 2 plus root 3 or root 3 minus 2. They wrote it the nice way with the square root at the end, because that way you don't get confused as to whether the square root should keep going or whether it stops. This is really clear. That one could be a little confusing depending on how messy you write. So this was them simplifying this big old plugging in idea from the formula. Number 30 was so easy it might have been hard because you had to take the formula and go backwards. You have to go from cosine sine and go to cosine of u plus v and then say, oh, cool, u is 130, v is 40, add 170. You have to go backwards with the formula. Same thing with 36, go backwards. Cosine sine, that's a cosine one. And the signs change, so I put the plus, and I take the u, and I take the v, I add them together. 1 pi over 16 plus 3 pi over 16 is 4 pi over 16. The reason they answered this one was because it was unit circle. The reason they didn't answer the one up above is because 170 is not unit circle, so they stopped. Because they wanted the exact answer as best you could. This one I could keep going. Number 58, you're going forwards on the formula using sine of u plus v. This is a t-proof though, right guys? Was it not a t-proof? Did it say verify? Or just t? It's a t-proof. So remember the book writes it fun. But the t-proof, you could have gone from this one to his formula. And then can anyone just real quick explain how they went from this step, which is the formula, to this step with like actual numbers plugged in sometimes? Yeah, louder. Unit circle. Sine of pi over 2, I should be able to find from the unit circle is 1. Cosine of pi over 2 from the unit circle is 0. Then 0 times anything? Haha! Cosine, done. 76. You didn't have to actually even use the formulas. They said that you were allowed to graph. And when you graphed, you were finding the zeros. And zeros, that's a function on your calculator, yeah? When you found the zeros in between, remember x min, x max, 0 to 2 pi, they told me where to cut it. If I make my x min, x max in my radian mode, you would have seen a 0 here at 0. And then you would have seen a 0 here. If you would have found it, it would have been 3.1415926. Who's that? 0. Wasn't even a hard one. Wasn't even like a crazy pi over 4 decimal that I wouldn't know. And? Oh. Okay, that's it. Section 5.4, do we have any questions on odds or evens needing more explanation? Joel, go ahead. 41 and 47? Okay. Let's go peek at that. AJ, what else? 41, 47, 11. Oh, you're thinking 5, 5. Not yet. Not yet. Sorry, 5, 4 first. So, 41, 47. Josh. 71. Okay, we don't like energy. He said 76. AJ. Let's go see if any of these are common, just to make sure it's not like a type of problem that we don't know, because that would be pretty scary. Uh-oh. Hello. There he is. Oh. Blue wheel of death. Hey. It's not really death. It's just me being impatient. And go team. Hey guys, go and get your pencil in section 5.5 notes so we can flip there quickly once we go over homework or finish homework questions. Go ahead and open up your notes to 5.5, get your pencil in there to be ready. So I'm going to go pretty fast. Alright, let's start with those ones that were around the 40s. Let's start with the ones around the 40s. 41 and 47, okay. Were very similar types of problems. Nice thing is, in our notes, since you have your notes and you open to 5.5, go back to 5.4 real quick, kiddos, in your notes. Go back to 5.4, and I want you to find the example in 5.4 that looks like the directions to all of these problems, 41 through 52. Find the example from 5.4 that looks like those problems. It has like a sign equal to a number fraction, or a cosine equal to a number fraction. There are patterns. We have to find the patterns. Did you find the example?
Yes.
Yeah. Cool. I wrote a hint, and I told you guys to highlight, star, circle. If you have not done it yet, you better do it now. Highlight, star, circle. The statement I told you underneath this example, I said, given ratios, make triangles. Make triangles or triangles, depends on what they give you. In this one, I'm going to say triangles because how many different angles do I see? 2. So I need 2 triangles. And they tell me, just like the directions in that example, put both triangles in quadrant 2. Now this section is different. This section says put both quadrants. Put both triangles in quadrant 3. So I need to make triangles. Now, on all of these, look, 41 through 52. Look at the problems. Aren't they all, or don't they all have formulas that go with them? They all have formulas that go with them. So here's the dilemma. Even though we have a formula for, say, 41, which, hey, let's practice our formulas. What's sine of u plus v?
Cosine b plus cosine u sine b.
Good. Now, do I have some of these pieces to plug in? Yeah, I know sine of u is 5 over 13. I know cosine of v is negative 3/5. So I can plug in for this guy, and I can plug in for this guy. But what's the problem? I need cosine of u, and I don't have it. I need sine of v, and I don't have it. So what do? Well, I plug in what I know, which is 5 over 13 is sine of u. Negative 3/5 is cosine of v. And then I say, all right, let me go find the other guys. And the only way to find the other guys is to think triangles. So in quadrant 2, you should have made a triangle for, let's see, 5 is opposite, 13 is hypotenuse. How did I know that for angle u? SOHCAHTOA. Sine is opposite over hypotenuse. Opposite needed to go opposite. Hypotenuse needed to go for the longest side. And if you used Pythagorean theorem, 5 squared plus x squared is 13 squared. We did that on class. We wrote it on that sideboard. I remember it. 169 minus 25 is 144. What's this side end up equaling? But why am I going to put a negative? It's going to the left. It's in the second quadrant. So now that I've drawn the triangle for you, what can I plug in when I need cosine of u? Well, look at them. What's cosine? Adjacent over hypotenuse. If I make the triangle and fill in the missing side, I have everything I need for cosine of u. So what do you think I'm going to do for sine of v? My other missing. Make a triangle. Now, not for you though. I need v, so I need to make another triangle in quadrant 2, and this time I'm going to label, well, you guys tell me, I'm going to label adjacent is negative 3, and hypotenuse is 5. You see where Chris and Jackie and Abby and others were getting it? Cosine is SOHCAHTOA, adjacent over hypotenuse. Adjacent is negative 3, hypotenuse is 5. Plug and chug. You guys hopefully know Pythagorean theorem well enough to know that the opposite side is going to be 4. Positive 4, right? Cool. So what's sine of v? 4 over 5. Last step, multiply, multiply, add. Given ratios, make triangles. If you make the triangles, fill them in, you have everything you need. So you guys walk me through number 47. Maybe not the entire thing, but at least how to set it up. If we can set it up, I bet we'll be all right. And why am I comparing 47, which is in a totally different section, to 41? What are you given? Got it. What do I need you to make? Exactly. But in number 47, we're going to have a little different formula, right? We're going to have, well, guys, practice.
Cosine u, cosine v, minus cosine u.
Sine
u.
Good. Good. Make sure you're studying 5-5 formulas too, but 5-4 is coming along. I could go ahead and plug in. I have sine of u, and I have cosine of v. I have sine of u, plug him in. I have cosine of v, I can plug him in. But I'm missing cosine of u and sine of v. Now, why am I about to, for you at least, why am I about to draw a triangle in the third quadrant? It tells me third quadrant. Another way of telling me could be saying angles between pi and 3 pi over 2. It could tell it to me that way too. But what am I going to label in this U triangle, cool kids? 7 is what? Positive 7 or negative? Because I'm going. Got it. And I've heard a few of you guys, hypotenuse is 25. Okay, now this one's a little harder because we haven't done this Pythagorean, at least not super recently. But 7 and 25, I bet that's a special one too. If I do negative 7 squared plus I don't know squared equals 25 squared, right? 25 squared would be 5 times 5 times 5 times 5? So 625, right? 7 squared is 49. X squared is equal to, any mental mathers, or are you guys doing a calculator? 576. Good. Does it have a square root? What is it? Nice. So x equals 24. This is another special Pythagorean triple. 7, 24, 25 is like 3, 4, 5, or 5, 12, 13. Question, am I going to plug in that 24 to be positive or negative?
Negative.
Because I'm going to the? Exactly. So what am I going to plug in when it comes time for cosine of u? Adjacent over hypotenuse. So I'm going to plug in my negative 24 over 25. I already know my cosine of v to be negative 4 over 5. I know my sine of u to be negative 7 over 25. I'm only missing one piece. And what piece is it? Sine of v. So I need to now make a triangle for v's angle instead, which you could do in the same place, but it's going to get kind of messy up here. So let me just do a different triangle. Still in quadrant, because they told me that. Negative 4 over 5. What am I going to label? 3, 4, 5, and then 4 goes on what side? Adjacent, good. So I'm going to have my negative 4, I'm going to have my 5, and it's going to be 3, right?
Negative 3.
Nice. Waiting for that, good job. So what do I plug in for sine of v? Opposite. What's the name of the game of PEMDAS? Multiply, multiply, and then? Subtract. Done. Okay, 41, 47, I know those are tricky, which is why I've had you look at your notes 3 different days, I think almost 3 days in a row, take away the weekend, and I've told you to highlight, star the directions. Whenever you are given,
Ratio.
you make a
Triangle.
bingo. AJ, what's your question, kid?
You also go over again.
58? I'm not going to write it up here, just because I have it down here, but I know that it looks funny here. How I would have done 58 is remember a T-proof. And in your T-proof, you have 2 sides to choose from, right? Why am I choosing this side? There's an equation for it. I mean, this one I could make 1 over secant. That doesn't look like that. So, I mean, what else could I do? I don't know. Tangent divided by, no, that doesn't even work. Cotangent divided by sine. Ew, gross. Cotangent times sine. Anyway, disgusting. I don't want to start on that side. This side has a formula. Sine of u plus v. So plug in. When I plug in, I get sine of u cosine of v plus sine of v cosine of u. Now, if they did it awkwardly, I would do sine of u cosine v, cosine u sine v. Either way. When you do the formula, plug and chugging, I can't say what cosine of x is because I don't know who x is. I can't say who sine of x is because I don't know who x is. This needs to stay. I don't know what to do with those guys. They're stuck. They're just expressions. But that guy's just unit circle, and that guy's just unit circle. And kiddos, how did the book figure out that this is 1 to plug in and that this is 0 to plug in? It's unit circle because pi over 2 is what angle? 90. And 90 is at the very end of my cheater chart for people that do the cheater chart, right?
Yes.
So when I'm doing sine counts up, right? 1, 2, 3, but that's for 30, 45, 60. It's counting up. 90 is going to be 1, right? So I have this, I have this, I have this, I can keep on going, but whatever's, right? Cosine. 1, 2, 3. Cosine goes 3, 2, 1, counts down. So this is going to be 0. And I could do all this to finish it off, right? Do I need tangent? No. So I know sine is 1, cosine is 0 at 90. Plug and chug. 0 times anything is 0. I'm left with cosine, and that's who I wanted. Done, done, done. Put a check, QEDs, shade a box, or draw what we're saying, chase here. Anyway, go for it. Number 76. Oh, no. You guys had other questions. Sorry, I got distracted. Then we need to look at the 60s and 70s. 61? 63. Kiddos, what side do you think I'm going to choose on 63? I mean, this is section 5.4. I mean, we were covering these formulas, yeah? So, I mean, I guess we could try cosine squared minus sine squared. We learned in section 5.5 that's the double angle of cosine, but I'm not really sure that helps. So number 63, I would choose the left-hand side. And I would plug in formulas. So the dilemma isn't necessarily, for most of you, hopefully, what side to choose. The dilemma was probably, well, for me, a computer, that's really slow. The dilemma was probably not wanting to plug in the whole formulas because they're nasty. Come on. Don't worry, I'm not typing, I'm just trying to wait. Come on. Wow, this is fun. Well, never mind. Never mind. All right, guys, as this opens, it's going to take a while. AJ, I think your question was 63? Can you just read me the formula real quick?
Cosine of x plus y
Times?
cosine x minus y equals cosine squared of x minus sine squared of y.
Okay. So if I was to go ahead and use the left side, which you guys all know or knew, I could go ahead and, hi, who are you? I don't know. I could use my formula, guys. I'm just going to go for it. So it's co, size change, minus sine. That's this guy. This guy is going to be co. I'm going to run out of room, so some of you do this in your teachers too. It's okay, no judgment. I'm going to do it too. Co. Plus sine. It's disgusting. It's awful. It's a difference of squares. A minus b times a plus b. First would give me cosine squared x, cosine squared y. That'd be my first. For a difference of squares, what always happens, I know algebra off to the side really quickly, if I was doing a minus b times a plus b, what happens to my outer and my inner every time? They cancel. That's algebra 1. So my outer and my inner, who cares? Last is going to be minus sine squared x, sine squared y. Doesn't match, but it's so close. Question, who's somebody I don't want to end up in my answer?
Sine of x.
Yeah, I don't want that guy there. Who else don't I want?
Cosine y.
Do I have any properties that can take the place of cosine squared of y? Pythagorean theorem. Careful, not 1 plus. 1 minus. So I can plug in 1 minus sine squared of y, and I can plug in 1 minus cosine squared of x. And guess what's going to happen when I distribute and simplify? I'm going to get that guy. Distribute and combine like terms, and I'm there. Because I have the cosine squared of x minus cosine squared x sine squared y. I'm going to have minus sine squared y and plus cosine squared x sine squared y. Those are going to cancel. I'm done. All right, let's go peek at the 70s real fast. I apologize for all the crazy technical difficulties. I know it's technology. What can we do, right? Let's come back to, what were the last one? 71 and 76. Let's get rid of that guy. Actually, cancel. Let's go with 76 real fast. Okay. And 71. Okay. 76 is using our calculator. Which I'm not entirely sure I can fully go over right this second. But let's look at number 71. Kiddos, is it a T-proof? Is the unit circle E1? Or is it a triangle one? What is it?
Unit circle.
Unit circle E1. But I cannot set, I don't even know. Unit circle E1, I'm stuck until I use the properties. And as soon as I use the properties, just like what we just saw in the T proof, as soon as I use the properties, as soon as I go away. Anybody? I don't know. Okay, we're not using the calculator today. That's not working. When I go to use my properties, am I going to get some unit circle-y things I can plug in?
Yes.
Yes. So when I get my unit circle-y things, the rest is going to be able to combine, and then I'm going to be able to use my unit circle to solve. So, long story short, when we end up using our unit circle-y stuff, we're going to end up with the signs change minus sine. And then when I plug into this guy, I'm going to get minus plus sine. Now the ironic thing is, wait, don't these terms look super, super similar? That's on purpose. All I need to do is very carefully distribute my signs, and then say, hey, look at these two guys. If I'm adding, what's going to happen?
Yes.
What's going to happen to these two guys? They're going to combine, -1 minus 1. And I can set equal to the other side, which is 1. And guess what? Sine of pi over 4, isn't that a unit circle one? 45 degrees, you would go to your cheater chart or go somewhere else, like the unit circle itself, and simplify. The nice thing is those two little 2's go away. I end up with negative sine of x equals 1 over root 2, which ends up being sine of x equals negative root 2 over 2, which should lead me to 45s in the third and fourth quadrants. So I end up with 5 pi over 4 and 7 pi over 4. Done to the left hand. Okay, the calculator one we'll have to save for maybe tomorrow if we have time on 5-5 questions. Here's the dilemma, 5-5. We wanted to get some more practice in, right? Now, for you guys, sadly, your notes are not in here from yesterday because the computer totally failed. However, we did get all the way through half-angle examples, okay? We did get all the way through half-angle examples. Here's what I'm going to do just for sake of time. I want you guys, if you have written down the product of sum formulas, which most of you didn't because we didn't look over them yesterday, I'm going to totally take any questions of the product of sum formulas off the Thursday portion of the test, okay? As a result, the homework problems that use the product of sum formulas, I'm going to take off as well, all right? And here's the reason why. Here's the reason why. If I'm not making you memorize them, I would love for you to be able to use them. But long story short, I don't think that's really going to be practical at this point with what we need to do. So I'm going to go ahead and have you guys turn in your homework spirals to section 5.5 homework. Let me go ahead and right now on the video, so anyone who's not here today can be doing this as well because they should be checking the video. Chapter 5 homework. I will go onto your Google Drive and I'll do a little strike through option. That way you can still see the problems, but they'll be striked through as in you don't have to do them any further. Okay, so section 5.5, let me go find the product of sum ones, and we're just going to skip those and go straight to example of bunch of formulas we've already seen. Which means you can take out we can cross out numbers number 10. Please don't put number 49. Number 62.
And that's it. You take out number 10, number 49, and number 62. And we will skip all the product to sum examples. Let's go ahead and go find an example that's not a product to sum one. That way we're not getting lost in those formulas that we're not memorizing. We won't need to waste time writing them down either. They're good formulas. They do have practical application later. But hopefully as you continue expanding your education, you learn that formulas become very helpful in many different fields, and you have to learn how to plug in, how to simplify, how to use in business and econ and physics and chemistry and so many different areas. But we won't overload you with more right now. So let's go ahead and go to this example. It's not a product to sum, it's not a sum to product. It just says verify. For some of you guys last night in homework, you might have disliked when you got to the 30s in section 5.5 when it was talking about making cosine to the first power. Those are the power reducing properties. The power reducing properties. So this one has us practicing that property. So in your notes, you should have this written down. You should have been studying the power reducing properties. They are one of the sections from section 5.5 that you need to be studying. Double angles are one. Power reducing is the other. And half angles are the third. Power reducing says, give me a squared and I'll give you a single. So what side do you think we should start with, guys?
Right side.
Because the right side gives us a square. Look at your formulas. Look at the power reducing formula. Look at the power reducing formula. It says, give me a squared. Now hold on, the 2 isn't a part of it, right? Okay, so just put the 2. He's just there. He's chilling. Now, cosine squared of 5y. His property says, give me a squared and I'll give you a single. And how does it work, guys? How does the formula work? Cosine squared of u equals 1 plus cosine double the u.
Yeah.
So who's my u currently? 5y. And what am I supposed to do to the 5y? Double. So what do I end up with? Cosine of? 10y. Oh my goodness, look at that. What happens to the 2's? Oh my goodness, I just had to use the formula. Just had to use the formula. Power reducing says, give me a squared, I'll give you a single. Maybe I'll change the argument, but still, he's not squared anymore. That's kind of like cool beans. Okay, let's go find, if we can, that's a separate product one. Alright, cool. So let me have you do this. I'm going to change these directions. Because one of you guys had a question in your graphing calculator, so let's go ahead and do that now. Let's see if we can get the graphing calculator to work, okay? So let me pull up the graphing calculator. Let me change the directions just a little bit. And let's say, find the zeros, or I should say solve, using graphing, what's your book say, graphing utility? Is that what it says? Oh, calculator. For x within 0 to 2. You guys know what I mean when I say pi, right?
Yes.
Okay, good. Alright, how would you guys go about following these directions? I have my y1 ready to go because graphing calculator, well, they must want us to graph something, right? So how am I supposed to solve? Don't ask, I don't know what's going on. Okay. How are we supposed to solve? I can even make it a little easier if you want. I'll change the problem just a little bit. How do we solve? If I was having to do it by hand, yeah, I'd split them up. But if I'm allowed to use my calculator, this is like number 71 from the 5.4 homework. If I'm allowed to use my graphing calculator, all I want to do is find when this side equals what? 0. And what do we have in the graphing calculator feature under second trace? We have the 0 function, but that can only happen when I have a function plugged in, right? So what am I going to plug in? Yeah. Make sure you're in radian mode, not degrees, or else it might get funny looking. I'm in degrees, so my answers would be way off. But now that I'm in radian mode, I could go ahead and graph cosine of, use your little pi, it knows what's going on, pi over 3. But hold on, I also need a plus x, right? Good thing is, calculator knows PEMDAS, which means it will keep the multiplication together and the addition separate. I don't have to do extra parentheses. But I do need the other piece of the puzzle, so I could go ahead and plug in my pi over 3 minus x. Now, why am I going to my window, though, first? What did the directions say? So, can't I change my x min to be 0 and my x max to be 2 pi? That way I'm only looking for the zeros in the region or in the area. Sorry, this was set up from a calculus problem. I need negatives too, huh? Let's go y min negative 10. But as soon as I change my x min to x max, Josh and Leo, to be 0 to 2 pi, then I can go ahead and look at my graph and say, hey, any zeros? And the answer is yes, of course, and they're right there, right? So we go ahead and actually use our second trace feature in order to use our zero. Go to your Precalc graphing calculator handbook if you don't remember. It tells you exactly how to do the zeros, how to go a little bit to the left of the zeros so that you're on the other side and you're going to hit enter and answer that question. Then it says you can go a little bit to the right. And hit enter, and then it'll find a zero in between. That would be really good. All right. Just, yeah. AJ, I know you had a couple questions on the 5-5 homework. Were any of them the ones that canceled out? Okay, so what did you have on the 5-5 homework? 11 we didn't like? Did anybody else get to 5-5 and get stuck on 15. Okay. Kiddos, I still have 30 seconds. 11 and 15 were some questions that we had. We did get to take away some of the crazier examples. I don't think there's going to be time for me to pull out the book, so let me see if I can just look at it and give you guys a couple of hints for getting through 11 and 15. For number 11, it gives you the following. Sine of 4x is equal to negative 2 sine of 2x. Here's my hint. There's no formula for this. Pause and wait. There's no formula for this. What can we do? Two things. One, if you really like the u plus v formula, couldn't you do 2x plus 2x? And use your sine of u plus v formula? Or you could make this sine of 2 times 2x and use the double angle formula. If in homework you see any 4x, 6x, 8x, you can split it up with addition into smaller pieces. Or you can split up with a double angle formula. Both of those would give you sine of 4x. Alright, 15 might be a little bit similar. Don't have time to look at it. You guys can go ahead and go to top.
Thank you.
Hopefully that helps. For tomorrow, setting up formulas. First thing.
It's one of us. I'll be waiting. Your phone is gonna die. I think it's gonna put it all the way under the phone and I just